What are you doing? Okay, folks, so today we are going to finish up all of the rest of the new material. As a reminder, on Monday, we will have our fourth exam. The fourth exam will cover, let's see, it started with trying to remember. I believe it started with metric conversions. And it included metric conversions, English conversions, conversions involving Avogadro's number, mass to mass conversions, and then balancing chemical equations, molarity, whether it's calculation of molarity or conversions involving molarity or dilutions, which we'll talk about today. So it's going to be a very math intense test. On the exam, you will receive the English to metric conversion table, but remember, you will not receive the metric to metric conversion table. You're expected to know that. You will receive Avogadro's number. You will receive the molarity formula, and you will receive the dilution formula. So that just gives you an idea of what to expect on this exam and also what you will be receiving. My goal after you take your exam Monday is to grade like a crazy person, because I have both your exam and an exam on Tuesday to grade. But I'm going to grade like a crazy person so that I can hand you back that exam on Wednesday and also give you a sense of where you stand at that time, so you know whether or not you need to take the final exam. On Wednesday, my goal will be, besides letting you know where you stand, it will be also to describe how to study for my final exam. As far as other grades that are still out there, you do have a homework and you do have a quiz that are both due on Sunday night at 11:59 p.m. So just as a reminder, I even made the quiz due at 11:59 p.m. on Sunday night. So if you want to do the homework first, you can. Not that it should matter. I tried to make sure it didn't include dilutions, which is the one topic I had not covered prior to today. Any questions for me? Okay, so what we're going to be doing today is we're going to pick up with a couple more examples where we use molarity as a conversion factor. And then I'm going to introduce dilutions, and then we'll perform some dilution calculations. So let's just start with this problem that's on the screen. Determine the mass of sodium bicarbonate in 250 milliliters of a 2.1 molar solution. I'm going to start by listing out the information that I was given. Whoa, where'd you go? I was given 250 milliliters. And I was given the fact that it's 2.1 molar. Anytime you see that capital M, you should rewrite that piece of information into its subunits. So this is 2.1 moles of sodium bicarbonate per 1 liter of solution. Now we want to rewrite the molarity into its correct units, because by writing that molarity into correct units, you can see that there are 2 units associated with the molarity, whereas the volume that was given of 250 milliliters, there is only 1 unit associated with it. And when you have a choice between something that has only 1 unit associated with it and something that has 2 units associated with it, always start your calculation with the item that has only 1 unit associated with it. So we're going to be taking this 250 milliliters, and that is what we're going to convert into grams of sodium bicarbonate. Now, the first thing I notice is that I have a volume of milliliters that I'm starting with, but the conversion factor that allows me to go from volume into an amount of material has liters in it. So one of the things that I know that I'm going to have to use is I'm going to have to use the metric conversions. Specifically, I'm going to be using the fact that 1 times 10 to the minus 3 liters is equal to 1 milliliter. The next thing I notice that I'm working with is grams. And anytime I see grams, I automatically know I'm going to need the molar mass. I have 1 sodium at 22.99. I have 1 hydrogen at 1.008. I have 1 carbon at 12.01. And I have 3 oxygens at 16.00. So the sodium contributes 22.99. The hydrogen contributes 1.008. The carbon 12.01, and the sodium bicarbonate, the oxygen contributes 48. So that has a mass of 84.008. That is 84.008 grams of sodium bicarbonate is equal to 1 mole of sodium bicarbonate. Having the 2 of the possible conversion factors I'll need, I'm ready to begin this calculation with the piece of information I was given, which was that 250 milliliters of solution. The first conversion that I'm going to use is to convert that milliliters into liters. So I'll use this first conversion factor. 1 milliliter of solution is equal to 1 times 10 to the minus 3 liters of solution. The milliliter portion was placed in the denominator so that the unit and the substance would cancel, leaving liters of solution. The next thing I'm going to do is I'm going to need to get that liters into moles by using the molarity. So 2.1 moles of sodium bicarbonate is in 1 liter of solution. Of that molarity, I needed the liters in the denominator so that the unit and the substance would cancel, leaving sodium bicarbonate. But I was asked for the grams of sodium bicarbonate. So I need to use the molar mass. Of the molar mass, the mole portion will go into the denominator, with the mass in the numerator. The mole portion was placed in the denominator so that the unit and the substance would cancel out, leaving mass. And now, because I have mass, I'm ready to calculate. And the answer comes out to be 44.1 grams of sodium bicarbonate. If I'm looking at this from a significance digit standpoint, it would equal 44 grams of sodium bicarbonate. let you do the next one in line. Okay. You should have found that you needed the metric prefix conversion factor of 1 times 10 to the minus 3 liters is equal to a milliliter. And you should have found that you would need the molar mass as a conversion factor, and the molar mass of CCl4 is 153.81. You would have then started out with your 450 milliliters. Your first conversion factor would have had the liters versus milliliters from the metric prefix conversion factor. The milliliter portion would have gone in the denominator so that they canceled, leaving liters. You would have then used your molarity to convert that liters of solution into moles of carbon tetrachloride. And then you would have used your molar mass to convert the moles of carbon tetrachloride into grams of carbon tetrachloride. Ultimately, the mass would have come out to 221.49 grams, which, if you are looking at significant digits, would round to 220. Questions? Yes.
Did you get the digits from the 450?
I actually got them from, so when you look at significant digits, you look at the digits in the measurements in the problem. So this one had 3 significant figures because of the fact that there was a decimal point showing, whereas this one only had 2 significant digits. And so my answer should only have 2 significant digits. Okay. We have 2 primary ways to make a solution. The first is what we've been sort of describing, and that is we can dissolve a solid in the appropriate amount of water to give the desired volume and concentration. So for example, let's take this problem that we just did. This is an example of how you would do it. So basically, we would have a flask. And I'm not very good at drawing flasks, but we would have a flask. In this flask, we would add 220, well, technically 221.49 grams of CCl4. And then we would add water to the 450 milliliter mark. In so doing, the solution that evolves would wind up being a 3.2 molar CCl4 solution. So that is one way by which we can make a solution. Again, we would add the solid to our container. We would then add water to the desired level. In this problem, that desired level was 450 milliliters. So we would add water to the desired level. And then we would shake it, and what would result is the desired concentration. Now, our second way is to dilute solutions. To make a solution of lesser concentration. The equation to help us with all of that is the equation, well, let me give you the generic equation that you may have seen in a biology class. The generic equation is C1V1 equals C2V2. Where C1 is concentration 1. V1 is volume 1. C2 is concentration 2. And V2 is volume 2. Now, this is a generic formula because the unit of concentration can be a variety of different units. It could be percent, it could be parts per million, it could be parts per billion, it could be molality. There's a variety of concentration units. But our focus has been on molarity. Which we represent with a capital M. So this equation can become M1 V1 equals M2 V2. And basically all we're doing is specifying the concentration unit. Now, folks, this is, let's talk about tricks with this equation. First of all, let's talk about wording. If you see the word of, it means keep that concentration and volume together. The second thing is make your units match if they don't. Make V1 unit match V2 unit. If they don't. Before performing the math. So let's look at an example. What volume of 1.0 molar NaCl is required to make 300 milliliters of a 0.40 NaCl solution? First of all, the first thing I notice is that both of these are talking about NaCl. That is your cue. If everything's talking about the same substance, that is one cue that you're going to be using M1V1 equals M2V2. The next thing I notice is I notice my terminology and I see the word of, meaning those pieces of information will be kept together. So M1 is going to equal 1.0 molar. V1 is what we need to solve for. Again, I see the word of, which is telling me to keep this information together. So M2 is equal to, and that's supposed to be molar. M2 was equal to 0.40 molar, and V2 was equal to 300 milliliters. The next thing I do is make sure my units are matching. The only one I got to make sure matches is the volume unit. And since I'm hunting a volume, they're already matching. Once you have that, folks, this is a plug and chug. So 1.0 molar times V1 is equal to 0.40 molar times 300 milliliters. 1.0 times V1 is equal to 120. So V1 is going to equal 120 milliliters. Let's look at another example. What volume of 2.0 molar barium chloride is required to make 500 milliliters of a 0.50 molar barium chloride solution? First thing I note is that I'm starting with barium chloride, I'm ending with barium chloride. So this is a dilution calculation, and I will be using M1B1 equals M2B2. The next thing I note is the word of. So that means I am going to keep those two pieces of information together. So M1 is equal to 2.0 molar. V1 is what I'm going to want to solve for. I see the word of, and that's telling me to keep those pieces of information together. So M2 is going to equal 0.50 molar, and V2 is going to equal 500 milliliters. I make my units match, which they already do because volume, I'm looking for volume in one of them. So this becomes a plug and chug. 2 molar times V1 is equal to 0.50 molar times 500 milliliters. Or in other words, 2 molar times V1 is equal to 250. So V1 comes out to be equal to 125 milliliters. Questions about dilutions? I could ask for any of the 4 points. It just happens to be on this first two. I gave you volume. Let's do one more since we do have time, where I ask a different question, slightly different question. So you have an example of it. What is the molarity of a solution where 10.0 liters of 1.2 molar KNO3 is diluted to 2.5 liters? Okay, so again, we're dealing with KNO3 the entire time, and we're dealing with a solution here, so that means most likely, I'm gonna be using M1B1 equals M2B2. I'm looking for my ofs next. And I see one over here, that of. So it means I'm going to keep these pieces of information together. So M1 is equal to 1.2 molar. V1 is equal to 10.0 liters. The other pieces will go together. So M2 is what I'm looking for, and V2 is equal to 2.5 liters. So now I make sure your volume units match. And in this case, they do. If they had not have matched, we would have had to make them match. But then this becomes a plug and chug. So 1.2 molar times 10.0 liters is equal to a second molarity times 2.5 liters. So we're looking at 12, yeah. 12 is equal to the second molarity times 2.5 liters. So the second molarity is equal to 4.8 molar. Questions? That is it for new material. As you progress into your next course, if you have any questions, you're always welcome to come see me. My office will not change. And so I will always take my students back and answer their questions. So don't hesitate to come ask me questions. With that, that's it. I will see you on Monday. And I'll try to get this video uploaded before I leave today so that